In the previous BGP labs, I enabled iBGP session between R1 and R2, and I enabled eBGP session between Internet 1 and R1. I also advertised 4 prefixes on Internet 1 towards R1. Let's see what those prefixes are real quick. Let's jump to, first of all, Internet 1, show run, section router BGP. And these prefixes are Class A network, but they are subnetted with Class C subnets. If that's the case, if the mask of a network of the interface, and one loop back for as an example. So if this is a Class A network 100 and has a Class C subnet here, not matching exactly Class A, when advertising that into BGP, we need to specify the address of a network with a keyword mask and actual mask found on the interface. And these are now being advertised towards R1. So show IP BGP, and we can see them as best path valid and they will be installed into a routing table. So show IP route BGP shows them as BGP, marked with BGP here, coming from BGP source, and they are installed in the routing table. Now, there are 3 attributes that are always mandatory when the advertisement is sent. One of them is next hop. So next hop is basically this column here. We have this next hop, and second is AS path, which paths we would have to cross to reach those. It comes from path AS number 100. So there's only in the path there's only one AS. And the origin code, we'll talk about those later, but for now I want to focus on next hop attribute, which is all these 3 are mandatory. They have to be present in the BGP advertisement. This one is important because when the router receives prefixes, the first check it does is my next hop address reachable? So do I have it in the routing table? So if I do know how to reach this, now this is a directly connected network, so I know how to reach that. This is a subject for prefix installation into the routing table. Now why am I saying that? Because in our picture here, we are re-advertising those prefixes to R2. R2 is learning them via iBGP session. And there's one thing we need to notice here. So let's jump on R2, show IP BGP. So we do receive them here, those 4 prefixes from R1, but you look at the next hop attribute, it didn't change. So in case of BGP protocol, whenever prefix is advertised over eBGP and then re-advertised over iBGP, the next hop address of those prefixes does not change by default, which is going to create a problem for me here because R2 cannot install them into the routing table. Why not? Because the next hop attribute here, show IP route, is not reachable. I don't have a default route. I removed them from the previous labs, so it doesn't know how to reach that next hop. As a result of that, show IP route BGP, it cannot install them into the routing table as BGP prefixes. So that is the fundamental first rule in BGP. The next hop does not change if it's advertised over eBGP first and re-advertised over iBGP. If R1 had another AS system and re-advertised the same prefix over eBGP, it would change the next hop attribute pointing to itself. But this is not the case with iBGP re-advertisement here. So how do I fix that? In fact, actually, if I were to troubleshoot that, if I see that, obviously this is the indication, no best path, but if I want to see the details, show IP BGP, let's say 100, 10.10, one of them. It tells me clearly, hey, this next hop attribute in my prefix is inaccessible. It's been advertised by R1, this is the R1 ID, and next hop is inaccessible. So how do I fix that? There are at least 3 different methods to do that. I'm going to save the best for last. So the quick and dirty, since I'm running OSPF here, one of the methods, I don't like this method myself, but it's a method. I could basically tell that this network does exist in OSPF. Now, how would I do that? I can go ahead and say on R1, so my interface that is connecting me to the internet is Ethernet 03.10. Now this Ethernet 03.10 show IP OSPF interface brief is not part of my OSPF cloud. So OSPF is not running on this interface. So one of the methods, and again, this is not the best method, would be to advertise basically this network into OSPF. How would I do that? Now, there's basically simple way of doing that. Conft router OSPF1, and I would say network 10.1.10.1 with wildcard mask all zeros, meaning matching exactly that interface. Put this in area 0. And right now, if I go back here, my next hop is reachable is known via OSPF here. So show IP route BGP. Those get installed into the routing table. Now, why do I not prefer that method? Because there's more hassle. First of all, I need to enable that, and now I'm sending actually hello packets towards Internet 1, trying to establish OSPF connectivity. That's probably wrong on the Internet. It wouldn't work anyways, but why would I even send information about OSPF towards that router? Well, there's a way of preventing that. I could say passive interface. So right now, do debug IP OSPF hello. I am sending those packets. Let's see that. Right here, I'm sending packets over that interface for no reason, but I can stop it. I can say passive interface and specify what that interface is. So in this context, I am no longer sending hello packets, and interface is still part of my OSPF, and R2 knows how to reach the next hop address in BGP. In the next one, I'm going to show how to in the next video, I'm going to show how to maybe change it the next hop using a different method, for example, route map. And ultimately, I'll finish with the next hop self command, which is probably the preferred solution here.